All right, page 2, or page 3, excuse me, of the chapter 2 sample test, and our parent function here appears to be the square root of x. So I'm going to start it over towards the side here because the square root's all in the first quadrant. So I'm going to put my grid right there, x, y, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and so my square root function looks something like that. Putting on my unit so I don't get docked points. Alright, and now I have one number inside and one number outside, so I can do either one of them first. I'll choose to do the -3 first. So if I put the grid in the same place, don't have to, but I think I can go down 3, so the -3 is a down 3 shift of this. So this x, y, the 0, 0 goes to 0, -3. The 1, 1 goes down 3 to 1, -2. And the 4, 2 goes down 3 to 4, -1. And it looks like that. And out at 9 it would be at 3, crossing the x-axis. Alright, and so now I got to do with the 2 on the x. So I'm going to still do it pretty much the same place for the grid lines, x, y. So the 2 on the x is inside, and so it's going to do opposite what I would expect, and so it looks like it's going to double the x values. So, but since it's inside, it does the opposite. It's going to make them half as far. So half as far from the x-axis. Well, I mean on the y-axis. 0, -3 is on the y-axis, so it's not going to move. 1, -2 is going to go half as far from the y-axis, so it's going to be half 2, -2. And the 4, -1 will be half as far, so it's going to be 2, -1. And just so you know, the 9, 0, square root of 9 was 3, but it's down 3, so it's 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, it'd be about here, is going to be half as far. So instead of 9, it'd be 1, 2, 3, 4 and a half, 0. And so I don't get docked points. Put 0 and I'll put 2 up here, and so I got enough to recognize units. And I've done all the transformations. This is a horizontal compression by a factor of 2 towards the x-axis, and that's what the 2 on x does, and this is the -3 outside. So that would be 7b. Now 8. 8. Determine whether the following are odd, even, or neither. So a is y equal 2x squared minus x. Well, the squared's making me think even, that making me think odd, so I'm thinking neither. All I have to do is to prove that I don't get the same or opposite values for opposite x's. So I'll put in -1 and see what I get. -1 squared is 1, times 2 is 2, minus a -1, which would be 3. Now I'll put the opposite of that in, 1. 1 squared is 1, times 2 is 2, minus a +1, so 2 minus 1 is 1. So changing the sign of the x didn't leave the y's alone, and it didn't change the sign. If it left it alone, it would be even. If it changed the sign only on the y, it would be odd. It did neither. So now I'm going to do it for the next one, which is y equals the absolute value of 0.5x. I'm just going to write half x. I like that better, but you might like 0.5x plus 1. So this time I'm going to do the same kind of test. Absolute value tends to be even, so I'm going to put in a number that it's easy to take a half of. So I'm going to use 2. So I'm going to put in, I'll put in 2. Half of 2 is 1, plus 1 is 2. Absolute value of 2 is 2. Now I'll put in negative 2. Half of negative 2 is negative 1. Plus 1 is 0. Absolute value of 0 is 0. So the y did not stay the same, so it's not even. The y did not just change in sign, so it's not odd. So it's and C. That looks squared. That looks like it could be even. Let's find out. So I'm going to put something in here that's easy. I'll put in, but it's got to be able to tell the difference from positive and negative. So I'm going to put in 1 again, or negative 1 first. I don't care. I'm going to put 1 in. 1 times 2 is 2, plus 1 is 3, squared is 9. Now I'm going to put in negative 1. 2 times negative 1 is negative 2, plus 1 is 1. Negative 1 squared is 1. The y didn't stay the same. The y didn't change sign. This one is a neither also. That would be evil if I did all of them as neithers. But I could. Yeah. Oh, and number 9. And let's see here. So it says the equation, the y values on the line are just 5 minus x. And P is any point located over here, x. And it says find a function for the area of the rectangle. Function of x. Area, function of x. Let's see, its base, which is x, if it's over x. We can't say it's 2.47 or whatever that is because x is moving. And the height is y, so it'd be x times y, because width times height, or length times width, or whatever you want. But y is 5 minus x, so it would be x times 5 minus x, and now we have the area as a function of x. And I could ask on the test, where would I put x to get the max or minimum area? And so I would graph y equals this and then find out where the area, no, actually would be maximum between 0 and 5. Okay? I might do that. Who knows?